So this is the, we don't have any new staff this year, so I'm sure everyone has seen most of this presentation before. This is basically going to be just an overview of climatology for winter in terms of snow and ice, the patterns that typically bring us our snowstorms and cold waves and so forth. And then also we'll look at an outlook for the upcoming winter. Okay, that's the table of contents essentially for the presentation. So start with averages and normals. We'll look at the climate patterns, El Nino, La Nina. You'll notice there's one with a strike through it there, the Atlantic Multidecadal Oscillation. Dr. Mann up at, I believe, at Penn State University, who basically did the research that said the AMO was a thing 20 to 25 years ago, recanted it earlier this year, came out with a really well-researched paper and article that went along with it, basically saying that, hey, we goofed on this. This is the way science works sometimes. You find data that supports a position, but then later data disproves it. And his later research is showing that of the historic events, he was able to locate 16 in his original research, that 11 of those actually were not any sort of climate oscillation. It was actually just amazingly well-timed volcanic eruptions and then human effects with sulfate pollution that caused an apparent cooling across the Atlantic Ocean. And so essentially the AMO is dead. We're not going to talk about that anymore. He says that it was misapplied and is not actually anything we have to worry about. So El Nino, La Nina, and then the NAO, the North Atlantic Oscillation, those are obviously still in play. We'll look at the historic winter storms that have affected us, specifically the Christmas '89 and February '73 events, and then go into the outlook for this winter. So looking just at winter, obviously the 3 months of climatological winter, we're starting today, December 1st. It's the 3 coolest of the year, with average highs generally in the 50s here in the Eastern Carolinas, average lows generally in the 30s. Every day, though, you have the possibility of getting toward 80 degrees. We do have records even here at the coast of 80 degrees all the way through the middle of January. It's interesting that we're about as far as far north as you can go, where you still have that possibility of having 80-degree temperatures even in the middle of the winter. If you remember back to, I believe it was Christmas of 2016, perhaps, we had 80 degrees set records on Christmas Day. So it does happen fairly recently. Record lows during the wintertime, of course, teens, some single digits. We even have been down to a rare 0 degrees. That happened here in Wilmington, Christmas of '89, and it happened in Florence in January of '85. And we'll talk about both of those events later on as well. In terms of precipitation, we're unique around the world in that we have fairly well distributed precipitation throughout the entire year. Even the wintertime, we average 3 to 4 inches of rainfall per month through the winter. That's, of course, in an average winter there, and that makes the entire winter average anywhere from 9 inches inland to around 11 on the coast. And here in Wilmington, that's ranged from as little as barely 3 inches back in the 1889-1890 winter to over 23 inches back in the huge El Nino winter of '97-'98. So obviously a lot of variability that can be pressed on us from external sources there. Snowfall, it's interesting that they have not updated the snowfall map, the climatological map for the new 91 through 2020. I'm still looking for that to appear, but it hasn't changed a whole lot. It has fallen across our area. We're now, for the first time in history, Wilmington's average snowfall is less than 1 inch. And that's never happened in the entire history of Wilmington, where you could actually compute a 30-year moving average. So it's the least amount of snow we've ever had in this climate here since humans have been keeping records. Inland, it looks like about 1.2 or so in Florence. We don't have really good records for Lumberton, but I would think it's about 1.5 to 1.6 up there. So we're somewhere in that, ½ inch along the South Carolina coast to maybe close to 2 inches for our northern counties inland. Some of the lowest numbers we've ever seen here. The fact that we still do get snow means that when we do get that rare, infrequent snowstorm, that the impacts on society are enhanced because we're not really used to it. We don't have the equipment or the know-how really to deal with those rare snowstorms. When it does snow, February and January, those 2 months there make up about 2/3 of all the snow events that we have in Wilmington. It does rarely snow in December and March. There's even a couple of historic events in November, but certainly January and February are the 2 months you would expect to see snow here in the Eastern Carolinas. So looking at some of the climate oscillations that have big impacts on our winter weather, the big one is the ENSO circulation, El Nino Southern Oscillation, and that basically it's a natural seesaw. On one end is El Nino, the other end is La Nina. It's modulated by sea surface temperature anomalies in the eastern tropical Pacific Ocean, and you can see infrared photos there from a strong El Nino and a strong La Nina showing the big shifts. Anything above a ½ degree Celsius variation from normal, if that holds itself for 5 months, they say, okay, now we're in an El Nino if it's warm, or a La Nina if it's cool. And of course, the impacts on that spread out well beyond just the Pacific Ocean. It really literally covers the entire planet with impacts. Here in the Carolinas, our biggest impacts in the wintertime with El Nino, this is not the pattern we have this year, but with El Nino, we have a cool and wet winter, not necessarily because there's a lot of Arctic air in here, but because we have, every time a cold front comes through, you have a very, very active subtropical jet pulling moisture off all the extra thunderstorms down in the tropical Pacific. So every system comes through loaded with moisture. There's also, with an active subtropical jet, you have more individual disturbances that produce more synoptic scale lows. So an El Nino winter for us tends to be cloudy, cool, and wet. And that was when I showed the wettest winter we've had in history here, that 97, 98 winter. That was a powerful El Nino that certainly lived up to all of it, what it was supposed to do here. The opposite, this is what we have in place this year, is La Nina. That's when the eastern tropical Pacific water temperatures are below normal. In this case here, every time that a storm system crosses by, there's very little subtropical moisture because there's very little convection across the eastern tropical Pacific to pull moisture in from. Given the fact also that the subtropical jet is weaker, the main polar jet is lifted farther north, we have just fewer individual opportunities for storm systems as well. So a lot of factors working against getting rainfall here. In a La Nina winter, we typically average with a lot of clear skies, dry weather, and above normal temperatures, and that certainly is what we're expecting for this winter. And this is the official CPC forecast just issued last month, saying there's a 90% chance that La Nina will continue through this winter, and that drops to about a 50% chance once we get into mid-spring. It's interesting because we are in a moderate drought for most of our area now. I listened to a talk several years ago from Pam Knox. She's one of the climatologists in Georgia, who said that for the southeastern U.S., when you switch from a La Nina to an El Nino in the summer, which is a possibility, that tends to be associated with the worst drought conditions across the southeast. So going into winter with a drought already in progress, this is not necessarily something we want to hear. But at the bottom of the screen is our current SST anomalies. You can see a lot of cool water across the eastern tropical Pacific. That is the La Nina that's already in progress there. Now, another factor that became really big news back in the 2010-2011 winter, when we had a really big Arctic outbreak that winter, is the polar vortex. You hear that word thrown around, sometimes misapplied a little bit, but also its impact on the North Atlantic Oscillation. Now, this overwhelms everything else that's going on. It doesn't matter if you're in El Nino, La Nina, anything else. Whatever the NAO does here will overwhelm everything. It's essentially a shift in its positive phase. You have a very strong Icelandic low and very strong Azores high with a very fast west to east jet between those two. In that case there, which is actually what we're going into for the first half of December, looks like, all the Arctic air stays bottled up north. Canada and Alaska have below normal temperatures. You have a powerful jet that separates that from very mild weather across the, most of the United States, especially the southern half of the United States. In this case here, we average, well above normal temperatures, which is what a lot of the 6 to 10 and 8 to 14 day outlooks have been showing recently. The opposite phase of that is when the Icelandic low and the Azores high weaken. You end up with a weaker jet, but also one that has a lot more of these north-south oscillations in it. And when that occurs, cold air tends to drop south across the big continents in the northern hemisphere, that of course being North America and Eurasia. In those cases, we can get extremely cold. Cold air will blast south all the way into the subtropics across North America and Europe. If you think about the January 2018 extreme cold wave, for those who were here for that, that was a classic negative NAO pattern there, where we had cold air lock into place. It lasted for, I think, 8 days here, where we had extremely below normal temperatures. So this is only unfortunately predictable 1 to 2 weeks in advance. So there's no way to tell what impact NAO would have later this season, other than to say we have to watch for it just to see. So when the NAO goes negative, I mentioned we can get extremely cold. Well, here is that all-time record cold outbreak for most of the southeastern United States. That was January 21st of 1985. On this event here, Mount Mitchell set the state record for North Carolina, -34. You can see records set it for the states and for individual locations all across the area. Wilmington got to 5 that morning, which was at the time the all-time record low. But then just a few years later, Christmas '89, we got to 0 and broke that. But this was, for most locations in our CWA and across the Southeast in general, this January 85 event is going to be the coldest event on record. So let's look at patterns associated with snow getting winter storms here in the Carolinas. The prerequisite you need for everything is cold, dry Arctic air in place. Not just cold, but dry is actually a big part of that. If you think about where does our moisture come from, it comes from a very warm Atlantic Ocean that sits just offshore. You've got to have dry and associated in addition to the cold, because you need the evaporational cooling to offset the warm air that's going to try to come in with that moisture you're advecting in. So cold, dry Arctic air has to be in place. There needs to be a front stalled across central Florida, and then a low needs to form in the Gulf of Mexico. So you can picture a disturbance coming across Texas, the southern Gulf Coast, induces a low to form. This is about, to use a little NASA parlance, S minus 24 hours. We're 24 hours from the onset of snow in Wilmington. Low pressure begins to develop in the central Gulf there. Advanced 24 more hours, the low by this point here has moved to maybe the west coast of Florida around Tampa. At this point here, snow is now beginning to fall across the eastern Carolinas. It's interesting that with the path of the low, we need to keep a north wind here in Wilmington and the area. A north wind will maintain that cold, dry flow of air. If it goes northeast, we start to drag in much more moisture off the Atlantic that can't evaporationally be cooled then, and you end up with a transition over to rain or ice at that point. So north versus northeast is a big low-level wind clue to what kind of precip you might can expect here. So it snows for 12 to 24 hours. The low then moves off the southeast coast there on its way either up to the northeastern U.S. or out to sea. There is a benchmark point out there, 30 north and 75 west. The low needs to cross very, very close to that point in order for this to be a snowstorm for us. Any closer into shore than 30, 75, you usually end up dragging in a lot of warm air, and it transitions over to either ice or rain. If it moves farther south from that 30, 75 benchmark point, then usually the core of the QPF, the precip, stays farther south. We end up with either flurries or just a lot of dense mid-level clouds, and really not a significant storm for us there. So you can see how, number one, you need the cold Arctic air, which is a little rare in itself. And then while that's in place, you also need a low to go through this little small pinhole position off the coast there. So it's no wonder that snow is such a rare commodity across the eastern United States. Now, if you remember way back to college when you were learning your synoptic meteorology, if you had a good Dr. Brotek-like professor, like I had, he would teach you about the difference between a Miller A and a Miller B storm track. Well, this, of course, with a single low pressure system, he would call that a Miller type A storm track. That's the best one for us. The alternative to that is a Miller B storm track. That's when you have a low pressure system that takes an inland track across the mid-south up into the southern Appalachians. That original low weakens and it moves into cold air. You don't really have temperature contrast back in there, but then a new low forms along the coast closer to that pre-existing baroclinicity on the west side of the Gulf Stream. In this case, it's not really a good snowfall pattern for us because we typically have a lot of warm air aloft, but depending on how much cold, dry air is trapped at the surface, we can end up with ice here, sometimes even ice into Wilmington. It's been a few years, but way back in the 2014 winter, we had a very, very large ice storm, over ½ inch of ice. Did a lot of tree and power line damage across the Cape Fear area. We really haven't seen many significant ice storms recently, but a Miller B situation like this, given a lot of cold Arctic air, could be something to look for a big ice storm across parts of our area. So Miller A versus Miller B there. So the two big snows that we've had in history here, the big one for South Carolina, if anyone ever calls you up from Myrtle Beach or Florence saying what's the biggest snow we've ever had, mention this one here, February 1973. All-time snowfall record for the state of South Carolina was set in a little town called Rimini, R-I-M-I-N-I. That's just southeast of Columbia, 24 inches of snow there. You would think that for South Carolina, their all-time snowfall record might be in the mountains, but it's actually, basically eastern Piedmont, a little unusual. But this storm here, obviously a Miller A storm. You can see the animation of the surface map there shows the storm went across Florida off the coast. Even here in Wilmington, we picked up 12.5 inches. It was a tremendous storm all across the southeast. Certainly set a lot of records, from Georgia through the Carolinas. Made a lot of memories there, I'm sure. The big one for the Wilmington area was the Christmas '89 snowfall event. Also a single area of low pressure that formed off the coast. This was also coincident with an extremely cold, massive Arctic air. We ended up with 15.3 inches here in Wilmington. That's our all-time snowfall record. The town of Longwood in western Brunswick County had 20 inches. That was the peak of the event that was reported to the Weather Service at the time there. But you can see how from base of the Charleston area up through the Outer Banks. Just an amazing, tremendous amount of snow fell for that. Also, it was as far as I can tell, the only really white Christmas in Wilmington where you had a significant amount of snow on the ground. So certainly a lot of rare events thrown together there. The decade of the 1980s was our, in terms of low temperatures, one of our coldest on record here. You can see that 7 of the 11 coldest nights in Wilmington occurred during that decade of the 1980s. We used to talk about how that was possibly associated with that Atlantic multi-decadal oscillation. What it looks like now, reading through some of the Dr. Mann's thoughts on that, the 1960s, 70s, and 80s was a coal burning period in United States history, where so much electric power to support growing cities and industries was coal. That produces a lot of sulfate haze pollution, which reflects sunlight back, which caused regional cooling across the eastern United States and then downstream across the Atlantic. That's the current state of the research he believes there. So that's why it would appear anyway that the 1970s were cold, and in the 1980s we had all these incredible cold Arctic outbreaks across the U.S., with most stations really from Florida through the mid-Atlantic setting their all-time records during the 1980s. We haven't had anything, to make this list here since 1989. We did have a 10 in 1994, and then of course the January 2018 outbreak, we got down to 11 in Wilmington. So we haven't had extreme cold really since in any large scale since the 1980s really. So the outlook for this winter with La Nina in play, and not just a regular La Nina, but it's a double dip La Nina. We had La Nina last winter, then it came out of it during the summer, and then we're back into it for this winter. Double dip La Ninas tend to bring above normal temps and below normal precip, and you can see the CPC outlooks, the most recent ones on the screen there. They have pretty decent certainty about the temperatures. The precip's a little more uncertain because it's not a particularly powerful La Nina in the Pacific right now, so it's tough to say exactly how much impact that's going to have on the subtropical jet, reducing the number of disturbances there and how much moisture will be loaded up in that jet. But this is the outlook anyway that's in play for right now. The 3 factors at CPC is really waiting hard for this winter. The La Nina, of course, is number 1. And that's the picture there showing the SST anomalies across that tropical East Pacific zone. We had the La Nina last winter. We came out of it briefly in the summer, then we're back into it for this winter. And the forecast is, for high probabilities of La Nina continuing. The second factor they look at is trends, basically climate change. That they, if the graphic on the left there is from CPC showing temperature trends during the winter season per decade, their scale on the last graphic there, that first shading that we're into, is 1 to 2/10 of a degree Fahrenheit per decade. So that's been the trend since 1896. If we look more recently, the last 30 years, even their scale changes there, a little confusing, but the lowest level shading there is a 0.5 to 1 degree Fahrenheit, so much larger interval. But we're also in that where they're showing here, in the last 30 years, a more rapid rise in wintertime temperatures. So that goes into part of their weighting there as well. Seasonal climate models, another factor they look at there. I searched the internet looking for of the different models that they look at. They also have additional ones that I wasn't able to find. But going from clockwise from top left, we have the INSEP climate forecast system, the CFS model. This actually runs every day, and the graphics I've got displayed there, it's a average of the last 10 days worth of CFS runs, showing anywhere from 1 to 2 degrees Celsius above normal for the wintertime season across the United States. Now, something interesting about that CFS, and you'll notice it in some of the other models as well, you have below normal temps forecast across a lot of Canada and Alaska, above normal temps across the United States. That's an enhanced temperature gradient, which to me would imply you've got a very powerful west to east jet separating those two, keeping the cold air to the north and the warm air to the south there. So if you think in terms of the North Atlantic oscillation, perhaps a lot of positive phase this winter where the cold air exists and stays bottled up, doesn't really come south as often. That's how I would read that anyway. The CANSIPS model from Environment Canada in the top right shows essentially the same pattern, a little bit muted for our temperature anomalies. The UK Met and the ECMWF on the bottom also showing above normal for us. So pretty much it's unanimous. All the long-range models do indicate we have better than even chances of being above normal for this winter season. In terms of precipitation, they're also all showing a typical La Nina anomaly here. The CFS, their interval there is in millimeters per day difference, which is kind of a not very granular scale. If you think about a millimeter per day telescoped out over an entire season, that's 90 millimeters per day, or I'm sorry, per season, which is several inches. So really the edge of that contour there is showing that you're missing about a third of your precip. So I wish they had chosen a better way to display that data there. But essentially, below normal precip off all the models is what's being shown. And if there's any questions, I'll be happy to entertain those. That's the end of my presentation.